Hello students, how are you? I am Dr. Noor Tanis, currently working as Assistant Professor in Department of Physics, Jamshedpur Cooperative College, a constituent unit of Kolhan University. In this lecture, we are going to have an idea about the particle velocity and the phase velocity and their relation. You have an experience if you take a rope and you fix it one end and you take another end at your hand and you just give a jerk. What happened? The wave from your hand produced by your hand are transferred from the rope from this point from your hand point to the fixed end. What happens? The rope did not transfer. Okay, only the wave got transferred. So actually there are two types of motion here. One motion is the motion of the rope and the another motion is motion of the wave which got transferred. So let's see here. Particle velocity. Actually the individual particle which makes up the medium do not travel through the medium with the wave but oscillate about the equilibrium position. Means the particle of the medium, what was the medium in my example? The rope is not traveling, okay? They are actually oscillating about the equilibrium position. The velocity of the oscillating particle of the medium through which wave is traveling is known as particle velocity. Same is the case of our, when I speak, the particle next to my mouth get oscillated and then after touching it transfer oscillation to next particle and so on. This process goes on until the person who is listening me listen and his ear got the transfer of the vibration from the gas particle to his ear. Okay. Now what is wave velocity? Wave velocity, the velocity with which the disturbance of equal phase travel through the medium is known as wave or phase velocity. We discussed it earlier too. Relationship between particle velocity and wave velocity. Equation for the, we are aware, the equation for the simple harmonic motion is given by y is equal to a sin 2 pi upon lambda bracket v, small vt in minus x bracket close. Here what is small vt? Small vt is the velocity of the wave or also called wave velocity and y is the displacement at time t. Okay. Differentiating this equation with respect to time, we get the velocity of the particle. Now, if you differentiate this with respect to time, you get the velocity of the particle, and we are representing it with a capital V. Okay, V is equal to capital V is equal to dy upon dt, which will be equal to differentiation of this the 2 pi a v upon lambda into cos 2 pi lambda vt minus x. Now, what will be the maximum value? The maximum value of this velocity, particle velocity will be when this is maximum, and what will be the maximum value of this? That maximum value of any cos theta is plus 1. So, the maximum V max particle will be equal to 2 pi a v upon lambda, and where cos portion is equal to 1. That the maximum velocity of the particle actually is related to 2 pi a upon lambda into wave velocity. So maximum velocity of the particle is given by using this equation. Now again differentiating equation 2 with respect to time, we get acceleration. Acceleration is equal to d square y upon dt square, which will be equal to this much term. And since this term on rearranging, we get 2 minus 2 pi minus 4 pi square v square upon lambda square, and rearranging we get y. And what is the maximum value of the displacement? Maximum displacement is a, total amplitude actually. So y maximum is equal to a. So acceleration maximum will be equal to 4 pi square v square by lambda square into a, where a is the amplitude. No, the negative sign here, what it actually means? The negative sign here implies that the acceleration of the particle is directed towards the mean position, what we see in case of simple pendulum or any such oscillation cases. Now, differentiation of equation 1 with respect to x, we get d square y upon d square y upon dx is equal to minus 2 pi a lambda cos 2 pi lambda vt upon vt minus x. Now, using the equation number 4, we get that velocity maximum v is equal to dy upon dt is equal to minus v dy upon dx. So the relationship between the phase velocity, particle velocity and the phase velocity it is established. Particle velocity is equal to minus of the phase velocity into dy upon dx. This is the relationship between the particle velocity and the phase velocity. Thank you for listening this lecture.